Hello to all participants of the 24 Square Science meeting. This is a short presentation of the associated poster on Eumetsat's code-based resources for sea surface temperature training. My name is Dr. Hayley King, and I'm the lead marine applications expert at Eumetsat, and I'm joined in this poster presentation by my colleague Dr. Ben Loveday, who leads our Copernicus Marine Training Service. This work that's presented in this presentation is a collaboration between myself and Ben and his contract, which includes Dr. Aida Alvera Azca, as well as a collaboration with the Eumetsat Ocean and Sea Ice Satellite Applications Facility via Olivier.
Thank you, Hayley. So Eumetsat produce a range of sea surface temperature data, and the reason we do this is sea surface temperature is an essential climate variable, and its measurement is essential for us to understand ocean dynamics. And we operate these satellites under two different programs. We operate satellites under the Copernicus program, and we operate satellites as part of our mandatory missions, which are processed by our Ocean and Sea Ice Satellite Application Facility. Under the Copernicus program, we have the SLSTR, the Sea and Land Surface Temperature Radiometer Sensor aboard Sentinel-3. And as part of our mandatory missions, we have sensors aboard the METOP satellites, where we have AVHRR. We have Severian FCI aboard the Météo-SAT series of satellites, and we have VIIRS aboard NPP. And together, between our activities under Copernicus and OCSAF, we process this data to a variety of levels, level 1B through levels 2 and level 3. And then we have a series of resources that support the use of this, these products. And one of the avenues that we pursue is code-based tools to be able to support the uptake, use, understanding, analysis of these various data streams. Now, what we've done in terms of our resources is we've set up our code under a series of Git repositories, which are freely available and open source and available for everyone to use for whatever purpose they see fit. And this diagram you're looking at on the screen right now gives an overview of where you can find the various repositories that are geared towards the various different sensors or application streams that are relevant to the use of all of our data, but in particular focus on this slide, sea surface temperature data. So you can see we have a general project called EuMetLab, and if you just Google EuMetLab, it will take you to the Eumetsat. At the top, it will be the Eumetsat EuMetLab link, and under this you can find links to all the various sensor-specific and application-specific Git repositories that you will find relevant to all of our different data streams. So inside these repositories themselves, they're mostly set up as a series of Jupyter notebooks, and these focus on various workflows that are relevant to working with sea surface temperature data. Some examples shown here are working with level 1B data to look at the brightness temperatures from individual channels to get an idea of what channels are in use and available both at daytime and nighttime. To do spatial-based plotting of data at level 2 in example B, and level 3 example C, and not shown here but also level 4 data from the Copernicus Marine Service. We show you how to calculate climatologies, how to calculate anomalies. We show some examples of time series analysis, including marine heatwave detection using the Hobday et al. 2016 toolkit. And we've also got some more advanced workflows that show you on a sensor-specific level how to quality flag data, how to look at the algorithms that were in particular used for retrievals in a given pixel or across a given scene, and give more information about how these products may be used and the caveats that may be required to work with them individually. This list is not exhaustive. We encourage you to check out the resources to find more about specific workflows that are there that might be relevant for your work.
So marine training at Eumetsat forms part of our wider user engagement activities, and towards this we produce a whole bunch of different resources that are available as standalone learning tools or information sources, whether you're learning or whether you're just looking to find out a particular bit of information about the data we offer. Upcoming soon, we have a new user portal. This will be coming online in the next couple of months, which will be the one-stop shop for all the information you might need technically about our missions, but also you can find information there about different case studies, different courses that are available from us to learn more about how our data works. As Ben mentioned, we distribute our code through our GitLab, and this comes in the form of a variety of different Jupyter notebooks. These are also deployed on a couple of different cloud services. In particular, to note is the Wekio platform, where you can actually access free resources to run these notebooks yourself. And these resources form part of many of our courses. If you visit our Moodle page, you can see the courses that we have currently open for application, as well as some standalone ones that are available from previous courses that you can have a look at. We also produce video tutorials. They're hosted on our YouTube channel. And as I mentioned, we also produce a variety of case studies. Through these, you can find different ways that our data is used. A number of these are actually linked with actual workflows in our code base so that you can recreate the analyses that we've conducted yourselves. This is just an overview of the team. So you can see me there, my colleague Sally, who work at Eumetsat. And then we have on the right-hand side of the diagram, Ben's contract, which contains a number of different experts who can provide information about ocean colour, sea surface temperature, as in the case here, and about altimetry as well.
Just a quick note on this slide, missing is our colleague, Dr. Olivier Monbrive, who works at Météo-France, but he is the training manager for the OCSAF service. You are currently looking at the Copernicus team, so Olivier should be on here as well. Now, all of the tools and resources that we've gathered together to support various thematic applications are usually couched against the backdrop of the events that are in our training calendar. And so we felt it was important to highlight the fact that our training may revolve around a slightly different set of paradigms than some of the trainings that you're used to. We have a series of events across the year, and I'll come to those on the next slide, but you should be aware that when we run our training, we always run our training where we can to be participant-led, which means it's up to you to decide that the journey that you want to follow through our training. We will help scaffold around what you want to learn with the resources we've got, but we try and gear as far as possible what we actually teach you around something that is of particular interest to you. We don't force feed you a learning journey to a specific endpoint. We let you decide that endpoint and we help you work towards it. We facilitate long-term data use, so data access is a core part of our activities, as you will find out if you attend the training during this science team meeting. And we focus on end applications that are situationally relevant and also fit within the paradigms of the working structures that you operate in. We selected the right data for the right task, so provide examples that are relevant to you. And we tend to build skills that are relevant to the modern EO sector, such as code-based learning as far as possible, and where we can, expansion into cloud-based environments. And we always align with open science principles, and we always include networking opportunities within our training. This is an example of how our trainings calendar was set for 2023, where we're nearly finished, and 2024. The 2024 calendar is starting to take shape. We have long courses in Q1 and Q4 next year. The long course in Q1, our supporting marine applications, is a somewhat introductory event for those that haven't worked with Earth observation data much before. It's a long form event, 1 month long, where we work towards your own specific application and outputs. You should look for the application registration coming for that in the next couple of months. And we also have a series of short courses that we'll be running across the year. Currently, the individual focus of those is TBD, but we will also be at the number of conferences next year with collaborating with a load of different experts in the field. The calendar is not finalized. If you have events that you are particularly interested in, where you'd like us to be there or think we should be there, please let us know, and we'll begin discussions about whether or not we can find ways to work together.
Thank you, Ben. As Ben said, one of the really important things to us is engaging with the community. So I would encourage you, if you have any questions at all, to contact us. The main email that you can use to contact us at Eumetsat is ops@eumetsat.int. This will contact our main help desk. And chances are, if you're asking an ocean-related question, you'll be put through to one of us. You can also use this to contact us to discuss any collaborative opportunities. As Ben said, we're very happy to work with you on training or to provide training at specific events that are relevant to the user community. This really helps us to tailor our training to things that are useful for you, which is the main aim for us in terms of driving data uptake. So please do feel free to get in touch with us with any of your needs. Thank you.
Thanks very much. One thing I will finally mention is the QR code on this screen links to the static PDF version of this poster. All the other QR codes dotted through the presentation link to the various resources we've referred to. If you have any more questions for us, you can reach us at ops@eumetsat.int, and you will hopefully see me at the symposium training teaching you about how to use Snap to look at level 2 sea surface temperature data and how to use Python to look at level 3 and level 4. Thanks very much.